It's not my problem if your bitch just wanna fuck on me. It's not my problem if your bitch just wanna fuck on me. It's not my problem if your bitch just wanna fuck on me. The way I'm spending man, they think I'm going broke. 200 for the Uber lock, take me home. This is G1, you know I am broken bones. She feeling me, now I got a fucking bone. She fancy, yeah, she got her hands on me. She got the Bambi handbag with the Bambi tea. I smoking bamboo, paper with the candy tree. And I'm sipping blue soda with some ice in it. I got money now, so I don't look at price of things. I got money now, so I really got ice on rings. I got money now, and you know my mother proud. I got money now, now I'm smoking super loud. I got money now, telly presidential suite. I got money now, so you know I'm smoking sweet. Ain't got no problem, but it's problem on this fucking beat. It's not my problem if your bitch just wanna fuck on me. I'm in the studio, hella high, so high, but I'm still hearing hella lies. It's hard to realize, yeah, these guys ain't your guys, yeah, they lie through their teeth as they look you in the eye. Yeah, I'm sitting in the corner and I'm on fire. Yeah, I'm doing white lines, yeah, I'm so wired. 36 hours awake, yeah, I don't sleep. A motherfucker like me ain't tired. Yeah, I try, but I don't even really try. Javinci t-shirt, white when I cry. Yes, eye for an eye, but I'ma take both eyes. Halloween killer, yeah, I trip and surprise. Dip into the shadow, yeah, you can't find me. Make sure you get followed home by these wide eyes. Dip into the shadow, yeah, you can't find me. Make sure you get followed home by these wide G's.
Hello guys, hello. Today is the week 4, day 1. Week 4. More like week 3, but it is week 4, okay? Week 4, day 1, and I just had open. Request हो चुका है. Let me switch. अच्छा ठीक है, 2 में काम करता है. Okay, so let's set today's goals. The first goal is to neural networks recap. ठीक है. The second is also wait. Left. The second goal is to do DSA. DSA में क्या करना है वो मैं जब देख लूँगा. DSA आई एम टारगेटिंग एटलीस्ट 5 प्रॉब्लम्स. ठीक है. नेक्स्ट व्हाट आई हैव टू डू सम ML प्रोजेक्ट्स, हैंड राइटिंग वाला. ठीक है. और रैप स्टार्ट. सो ये मेरे गोल्स है आज के. ठीक है. ये बहुत बड़ा दिख रहा है यार. ओके. हाँ, ओके, दिस इज फाइन and I'm really excited. Also one more thing. Topic. I have to also watch that talk of 3 brown 1 blue, 3 blue 1 brown. मैं तो नाम भूल जाता हूँ जब ये on LLMs. So I'm gonna start with that. And then बाकी सारी चीज़ें I think I'll go in this chronological order. Okay, so I'm gonna mute myself now and start करते हैं स्ट्रीम को. टाइम हो रहा है 12:13 and yeah, let's start.
Final fun. I've been working on this project about visual.
Also, that was transformers and not LLMs. Transformers. Okay, so let's start. यार मेरे को एक और चीज़ करनी है क्योंकि जस्ट बिकॉज आई एम सो एस्थेटिक का 14 ना, तो बुलेट पॉइंट कॉपी कौन सा वाला लूँ? This looks good. गोल्स के लिए भी कुछ ले लूँ क्या? लो, ले लिया. ओके, ऑल सेट. ठीक है, स्टार्ट करो. मैं
Visually explaining transformers, as he said. I love visually explaining all sorts of things, usually in math, but I'm happy to stray into the adjacent fields. The target audience here is always a little bit tricky, because I know many of you are engineers and are quite technical, but I don't necessarily want to assume too much background from people. The one thing I will sense for what those actual computations are, what the number crunching happening is, and why it's so conducive to parallelization, which is one of the big reasons for the success. So transformers were introduced in this now very famous paper called Attention is All You Need from 2017. And that paper was focused on a specific use case of machine translation. You might imagine it used for Google Translate and things like that. But since then it's seen a flourishing in all sorts of other tasks. It's not just useful for machine translation, but it's good for transcription with tools like Whisper. It's good for going the other way around, having tools that will take in a piece of text and synthesize speech. It's even good for image classification. It's a remarkably flexible framework. But the model that you and I are going to focus on today, which is the kind that's good for the success. So transformers were introduced in this now very famous paper called Attention is All You Need from 2017. And that paper was focused on a specific use case of machine translation. You might imagine it used for Google Translate and things like that. But since then, it's seen a flourishing in all sorts of other tasks. It's not just useful for machine translation, but it's good for transcription with tools like Whisper. It's good for going the other way around, having tools that will take in a piece of text and synthesize speech. It's even good for image classification. It's a remarkably flexible framework. But the model that you and I are going to focus on today, which is the kind that underlies chatbots, is a little simpler than the one that they introduced in that paper. The model is going to be one which is trained to take in a piece of text and then predict what comes next. So for example, here, if you feed it the text, "To date, the cleverest thinker of all time was," it's going to predict from its vocabulary what the word might be. But it doesn't just give a single prediction, it assigns a probability distribution to all possible snippets of text that might come next. In this case, there's a lot of possibility, so it has a relatively spread out, including some equivocation, recognizing it's going to use the words like probably.
यार I'm disabling my camera for some time because शायद इसकी वजह से स्ट्रीम में बहुत लैग हो रहा है.
or undoubtedly, arguably, that kind of thing. If you have a model that does this, that simply predicts what word comes next, you can turn it into something that'll generate new text simply by having it randomly sample from that distribution. You have it look over and weight it according to the probabilities that it gave, sample some word, tack that word onto the input that it was processing, and then run this extended version all through the process again, saying, okay, now that that word's on it, what do you predict will come next? Runs through the whole thing, which takes quite a lot of resources. And then again, it plays this game of sampling from that, tagging it on, and repeating. Now, a lot of people will ask why you would ever have it choose something that's not the most likely word if it generates that. You absolutely can do that if you get into the notion of something called temperature. This will come from assigning the temperature equal to 0. The answer is just you get very stilted outputs that sound kind of trite, and you get a little bit more creativity sometimes, or something that just sounds somewhat natural if you introduce that spark of randomness into it. Now, if you want to turn this into a chatbot, something that takes seed text and then extends it, the simplest way you could start for that kind of project would be to have your seed text establish an environment of a user interacting with some kind of hypothetical helpful AI assistant, take the user input that they typed into your chatbot website, tag that on into this input, suggest to it that what's about to be generated is whatever that hypothetical AI assistant would say, and then have the model start to generate those, again, one word at a time. Really one token at a time, but we'll get into that in a moment. So in this case, I took a relatively simple model and have it provide some suggestions for what to do while visiting Munich, and it goes through and does this random sampling process. And I'll leave it to you to judge whether or not its suggestion seems reasonable here. But it's kind of surprising that this should work, I think. The act of having something that simply predicts the next word would get you something that seems to have long-range thinking. And some of that comes from the way that it's doing that prediction and just how long-range the associations can be. So what I want to first do is show a high-level sense for how data flows through this whole model. We're not going to go into the details yet, but we will. Just how does it flow through? And then we'll dig into some of the things that I think are required to get that nice visual intuition we want to go for. So when it's faced with this task, it's given a piece of text, wants to predict what comes next, and the text could potentially be quite long, but I'll just show what I can fit on the screen. The first step is to subdivide it into little pieces. And we call these pieces tokens. In the case of text, they're very often words or little pieces of words, sometimes punctuation marks. But one thing to keep in mind is that it doesn't necessarily have to just be with text. Tokens could also include little snippets of an image or little snippets of a sound, if images or sound are somehow part of that input. Or if you're creating a different model that's doing a different task, like transcription or image processing. And the process there roughly looks like subdividing it into little pieces and then having some sort of vocabulary of what all possible little pieces are. Now, in the case of text, one little question that might be worth having in the back of your mind as we go through this is to ask, why not just break it up into characters? That seems like a much more natural choice for what the atomic unit of text would be, to break it into characters and then do with tokens there. And I just want you to think about that. So we're going to go through, and I'm going to return to this question. But as we do, think to yourself, what would go wrong? Why wouldn't this work well? Or maybe it would work into tokens instead. Broke it into characters instead. The first thing that happens, you have to know something about what happens to be able to answer that question. The very first thing is to associate each one of those tokens with a long list of numbers. And we think of those lists of numbers as vectors. We'll call it the embedding of the token. And you want to think of those lists as somehow encoding the meaning of each one of those tokens. And at this phase, it's essentially just a lookup table. Each particular token is always going to be associated with the same vector each time that you run it. But the first thing that happens is that you pass that through this all-important attention block, the thing that we're going to spend the second half of this talk to, which lets those vectors talk to each other in a certain way and pass information back and forth between one another, so that one that might have just started by encoding a given word might end up taking into account some of its context. For example, sometimes words can be ambiguous. If you take the phrase American shrew mole and the phrase 1 mole of carbon dioxide and the phrase take a biopsy of the mole, you and I read those and we understand the word mole means something fundamentally different in all three of those cases because of the context. So you want to give the machine a mechanism by which it can let words talk to each other so that that meaning could get updated. But it might not just be disambiguating the meaning of a word. It might be that you want to bake some sort of substance or essence of the entire context that's somehow relevant for predicting what might come next into a single one of these vectors. Because what happens here is it doesn't just go through this one attention block, but it's going to flow through many different iterations. So the next thing it passes through has kind of an overly fancy name. It's called a multi multi-layer perceptron. It's the simplest kind of neural network. When you break it apart, it looks like a couple matrix multiplications with a little nonlinear something sprinkled in between. I won't go into too many details on this particular block, but the one thing I'll say is the majority of model parameters actually live in this multi-layer perceptron. Despite the title, attention is all you need, in a sense of